Alrighty, let's see what we got today. Sum of k mirror numbers. Hard. A k mirror number is a positive integer without leading zeros that reads the same both forward and backward. Base 10 as well as in base k. For example, 9 is a 2 mirror number. The representation of 9 in base 10 is 9, and base 2, 9 are, and base 2 is 1001, which read the same both forward and backward. I wonder why they call it k-mirror instead of palindrome. K-palindrome numbers. Okay, but I think meaning-wise it's the same. On the contrary, 4 is not a 2-mirror number. The representation of 4 in base 2 is 100, which does not read the same both forward and backward. Okay. Given the base k and the number n, return the sum of the n smallest k mirror numbers. N smallest k mirror numbers. Okay. Input k is 2, so base 2, n is 5, output is 25. The 5 smallest 2 mirror numbers in the representation base 2 are listed as follows. So the palindromes in base 2, the first 5 of them are 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, and 1, 0, 0, 1. In base 10, it's 1, 3, 5, 7, 9. Huh, there's a nice pattern there. 1, 3, 5, 7, 9 is 25. K equals 3, base 3, n is 7. In base 10, the numbers are 1, 2, 4, 8, 121, 151, 212. Base 3 is those stuff. And the sum of the base 10 stuff is that. Is there even a pattern of palindromes? Like, I guess palindromes for base 2 is always this pattern, I think. For instance, the next one obviously is an odd 11. And that's... okay, never mind. 11 doesn't follow that pattern. Nice, nice red herring. So I guess base 3 and base 10 palindromes probably don't have having pattern associated with it as well. Interesting that base 3 doesn't have any zeros within the k within the numbers that are what do you call these? K mirror number. Yeah, there's no zeros in a base 3 k mirror number. Wonder if that's a hard rule. Base 7 and 17. These are pretty big numbers, although they didn't say for it to go mod, so I guess there's an upper bound, or the upper bound is within size of an integer for these constraints. K is going to be a base that is 2 through 9, so it's not going to be hexadecimal or anything above 10. N is, I guess it wouldn't make sense to be above 10, right? Because then the digits are going to be impossible to represent base 10. Is that right? It'd be weird. You have to figure out what symbols you're going to use for the higher value digits. And then 1 is the number of things summed is 1 through 30. Alright, so what to do here? Here, the 17th smallest K7 mirror number is in the millions, 6 million, 7 million, approximately. And if n was bigger than that, then obviously it'd be bigger than that. And maybe a lot bigger than that, considering that these numbers are kind of dramatically increasing in order of magnitude. I guess not order of magnitude, but dramatically increasing by a non-linear fashion. So I don't think it makes sense to iterate through every single number to test whether or not it's a palindrome in both base 10 and both base k. And then like counting the number of times that the corresponding number matches. So I guess I had to iterate through, construct a mirror number each time, and then test to see if the mirror number is a palindrome in the other base. I have to construct, I have to keep track of the constructions. Keep track of the constructions. How do you even construct it? Jesus. Well, I mean, for a certain number of digits. Alright, so let's consider the K7 and a 17 case. If you're dealing with a base that is smaller than 10, the first K palindromes, palindromes or K mirrored numbers in base K is going to be 1 through K minus 1 and then K plus 1, I want to say. So for instance, if it's base 7, then it's going to be 1 through 6 because those don't change at all when you go from base 10 to base 7. And then 11 is the first thing in base, the first palindrome in base whatever. 11 is like 1, 1. And then if you convert 1, 1 from base whatever to base 10, that would convert to be k plus 1, so it'd be 8. So if like k was, let's say, that doesn't quite work, right? If k was 9, then that doesn't work, actually. So if k was 9, then the first 1 through 8 would be a palindrome in base k, in base 9 and base 10, and then 11 in base 9 would be the same thing as 10 in base 10. But if it was something smaller than 9, so like 6, it'd be 1 through 5 and then 7. Alright, so, but that really is kind of a trivial case. So, okay, k equals 7, n equals 17. If I try to iterate through the constructions of k mirrored or palindromes in base k, I'll call it the k palindromes. Try to iterate through it. How would that go? 1, 2, 3, 4, 5, 6. Is that right? Yeah, 1, 2, 3, 4, 5, 6. Those are all same, base 7. And then the next one would be 1, 1. And then following that would be 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. No. And then 1, 0, 1. 1, 1, 1. 1, 2, 1, 1, 3, 1. And then 1, 202, 212. So in base k, you can't have a digit that is k or more. But then the palindromes are the same. If it's a palindrome base k, then it's a palindrome base 10. Interesting. If it's a palindrome base k, it's a palindrome base 10. Right? No. No, I'm thinking of that. Oh my god, I'm so stupid. That's not right at all. This thing converts to 7 plus 1 is 8. This thing converts to 7 times 2 plus 2 is 14 plus 2, which is 16. Like converting from something in base k to base 10, you treat each place value using powers of the base k instead of powers of base 10. So the ones digit is always going to be the same. It's going to be some number ones, but then the tens digit, or the tens, like the second to the leftmost place, is going to be the first power of k. So it would be times the first power of k. So it'd be 3 times 7 plus 3, 4 times 7 plus 4, 5 times 7 plus 5. It's just replacing what we normally have in base 10 with 7 as the base. So 7 times 3 is 21 plus 2 is 24. 4 times 7 is 28, plus 4 is 32. 35 plus 5 is 40. 42 plus 6 is 48. And then here it's 7 squared, which is 49 times 1 plus 1 is 50. Interesting, 50. Yeah, I guess that's just 2 more than the other one, right? Interesting. So like 99 in base 10 to 101 is 2 more. Interesting. Never really considered bases, palindromes and other bases before. So anyways, this is going to be 50 plus 7, so it'd be 57. 50 plus 57 plus another 7, so 64. Plus another 7 is 71. 80, no, 78. 85. 5 plus 161. 85 plus 161 is, or 85 plus 7 is 92. 99. No, I'm doing this wrong. 2 times 49 is 98 plus 2 is 100. Huh. And then plus 7 is 107. Oh, this should be 222. 114. 121. And then 121 appears in both this thing and this thing. Whew. Interesting. So, what does this mean? I think what's, so is it, do I need to construct both palindromes in base k and base 10 while I iterate? Is it better to construct in base one is faster. Looks like there's more. Okay, so let's consider the palindromes from base 10's perspective. Base 10's perspective, the palindromes would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 22, 33, 44, 55, 66, 88, 101, 111. So 121 appears as this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 121 appears as the 21st palindrome. If I just go through palindromes in base 10, if I go through the palindromes in base 7, 121 appears as 121 appears as the 7th one. 7, 8, 9, 10, 11, 12, 13, 14, 15. So it appears as the 15th one. Is that how I want to think about it? 121 appears as the 15th one here. Appears as the 21st one here. But then if I convert this thing back into base 10, if I convert these numbers into base 7, this would be 7 plus 1 is 8. And then this one would be, so if I treat these as base 7 and these as base 10, this is base 7, this is base 10, and then if I treat these as base 10, and these as base 7, 22 and base 7 is never going to have 8. Okay, how do you convert? So base 10 to base 7 would mean that you need to have some number that's equivalent to 11 value. So that's 1, 7, and a 4. 22 is 3 7s and a 1. 33 is 4 7s and a 5. 28 plus 5. 44 is 6 7s and a 2. 55 is 49, which is 1 there. And there's a remainder 6. And no 7s. No 7s. 66 would be 49. 66 minus 49 is 17. So that's like 1, 2, 3. 49 minus 37 minus 49 is 28. So that's like 1, 4, 0. 88 minus 49 is 39. So it's 1, 5, 4. Then 49 times 2 is 98. So it'd be 201. This would be 203. 2 more than the previous one. 98 minus 111 minus 98 is 12. No, 13. 13. So it'd be 2, 1, 6. 23 left over, so it'd be 2, 3, 2. 23 left over. Okay. So that's where they intersect. So it was, so 121 here is this 21st one down here. So 10 or 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It's the 21st one down here. And again, it's 8, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's better to go through. So in order to hit this thing, it's shorter on the base 10 version. So it's faster to iterate through combinations. I guess there's just more palindromes that are in base 7 than in base 10, like smaller numbers. Yeah, there's just more palindromes in base 7 than base 10 in terms of if you convert it from base 7 to base 10, it's more numerous. Like all the set of palindromes in base 7, if you convert it to base 10, it's a bigger set of numbers than for a given limit than the set of numbers in base 10 that are palindromes with that limit. So therefore you should iterate through the smaller ones, the smaller set. So that'd be the set of palindromes in base 10, and cross-verify whether or not that's a palindrome base 7 maybe. How I want to do this. Construct palindromes in base 10. Convert to base 7. Check. Oof. Oh gosh. That's a lot of palindromes. That's a lot of conversions too. Huh. So palindromes in base 10. 161 dot 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 191 202 212 dot 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 292 303 dot 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 393 44 dot 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 909 dot 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 999 1001 1111 1221 dot 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 1991 2002 dot 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 2992 dot 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 3003 dot 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 9009 dot 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 9999 dot 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 1000 or 10,001 10,100 no 11,000 no I would want to change here the hundreds, so 10,101 10,201 10,901 11,011 11,111 and then 12,021 then dot 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 12,921, 13,031, 13,131, 13,931, dot 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 19,091, dot 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 19,991 to 20,000, 2002. I mean, it goes up pretty darn fast, to be honest. Like, these are pretty big numbers already. So for each digit that you're adding onto your palindrome, it looks like it maybe is increasing the number of palindromes with that digit. Might be, what's 10 here? It might be like 100 here. So so 100, 101 to 191 is 10. And then for all the hundreds, that's going to be another 10 each. So that's going to be like 100 elements overall. There are palindromes there. 100 elements out of 1,000, roughly. And then in the next set, it's actually just, yeah, it's actually another 100. It looks like maybe the 100 goes from 0 to 9 for the 1,000, and then 0 9 again for the 2,000. So that's, yeah, another 100. Huh, interesting. It's 100 each. So 100 palindromes between like 99 and 999, 100 palindromes between 999 and 9,999. And then is this another 100 or is this another, like, let's see. So you need to go through 10 for the hundreds here. And then each of those needs to go through 10 for the thousands. And then each of those would need to go to 10 to the 10,000 spot. So this is the 10 times 10, which is 1,000. 1,000 palindromes for the 5 digits. And I think maybe 1,000 palindromes for the 6 digits as well. Looks like it's like 100, 100, 1,000, 1,000, like 10,000, 10,000 as the number of palindromes for each successive digit. Because with the even and odd counts of palindromes, or even length palindromes versus odd length palindromes, I think there's feels like there would be some sort of deal where it's only when you get to the odd palindromes that you actually change up a level of magnitude for how many there are. So for instance, if it's 2 digits, then there's just 10. But then because you go from 2 digits to 3 digits, it's now 100 different palindromes that are 3 digits. 10 times 10. But from 3 digits to 4 digits, because that's the 4 is basically the same thing as 2 digit. Or 4 digit is the same thing as a kind of 3 digit in terms of the number of palindromes. It stays at 100 more palindromes there. How does that even help? I don't know. Ugh. It took so long to get to this point. So if I iterate through my construction of the palindromes, verify that each number is a palindrome in the other base k, and then that's what I have to do. That's what I have to do. So if it's something that's this big, let's see. So 2-digit numbers can be 10 versions. A 3-digit number is going to be 100. 4 digits 100. 5 digits 1,000. 6 digits another 1,000. 7 digits can be 10,000. 8 digits can be another 10,000. 9 digits can be 100,000. 10 digits can be another 100,000. And I assume this is going to be within 10 digits. Yeah, those are 10,000, 100,000. I guess there's too many zeros. 10,000 would be 4 zeros, so it should be 5. So you're looking through at least, you're constructing 200,000, 230,000 or so, and then verifying it. Is that too slow? 200,000. Is there a faster way to construct it? Is there a faster way of determining the smallest n? Okay, well, time to just do the dirty work and see if it's too slow. The non-trivial dirty work. So how to iterate through the constructed palindromes in base 10. It's gonna be you iterate the, let's see, you don't always iterate the ones place because that matches the highest order place. You iterate over the innermost digit, and then if you can't do that, then you iterate over the secondmost. So it goes from inner to outer. Interesting. It goes from inner to outer. So do you do something like a reverse? Like if I ignore the front digit or the front half, maybe, if I ignore the back half, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 through 6, 19, 20, 21, 23, 30. Interesting. 100. 100, and then there's 10 again. So what I'm looking at is just the front half of the palindrome. So the front half of the palindrome is 1, and then 1 through 9, and then 10 through 99. And for a 3-digit number, you take that 2-digit number and you add in the tens digit as appended to the end. That makes it a palindrome. So it's 10 through 99. And then for the 4 digits, you take your 2-digit number again and you append the reverse of it. Interesting. So that's another 100, 10 to 99, 99. And then for 3-digit numbers, you take your, or for 5-digit palindromes, you take your 3-digit number and you append the reverse of the first 2 digits. So 100 through 199. and then 200 through, so that goes all the way up to 9,900, right? The biggest 9. And then for 4 digits, I think it's the same. You do the reverse of all 3 digits that you originally had. Is that right? Yeah, that's right. 1 1 1 1 1 1 1 0 2 2 0 1. Interesting. So that explains why it kind of keeps the same count of the number of palindromes for even, odd, or for the odd and the next even, because you're taking the same kind of prefix of your number. You're taking first like 3 digits here, and then like the first 3 digits here to create your 5 or 6 digit number, 6 digit palindrome. Okay. So I can construct, so yeah, so it looks like I can construct maybe or I know where how to iterate over my base 10 palindromes. It'd be iterating over all my numbers in base 10, that's 1 digit, and then all my numbers in base 10, that's 1 digit, plus that 1 digit again to create a 2 digit palindrome. And then all my digits in base 10, that's 2 digits, and then appending the tens digit as index to the back to create a 3 digit palindrome, and then the same 2 digits appended with the first with those two digits backwards for 4 digit palindrome. And then for 5 digits, then you take all your 3 digit numbers in base 10, like 100 through 999, and you append the reverse of the first 2 digits. So like 100 appended with 0, 1, 101 appended with 0, 1. And then for the 4 digits, and then the next one would be 6 digits. And you take the same 3 digit number appended with it in reversed. Interesting. So you're iterating over just that prefix number. So I'll summarize my thought here. To construct the palindromes in base 10, iterate over some prefix number and append some portion to create some portion of it to create palindrome. So 1 through 9 is just 1 through 9, and then so this is like 1 digit. 2 digits is going to be 1 through 9 appended with a self. And then for 3 digits, it's going to be 10 through 99 appended with tens digit. And 4 digit is going to be 10 through 99 appended with reverse. So like 10 plus 0, 1, 11 plus 11, 12 plus 21. So example 13 plus 31. And then for 5-digit, it's going to be 100 through 999 appended with reverse of first 2 digits. Like, let's say 103 plus 0, 1 becomes 100, 301. 6-digit is going to be 100 through 999 appended with reverse of all 3 digits. So example is like 199 appended with 991. So you get 1,991. Or 199,991. Okay. So is it better to create an array of this? Create an array of digits. Create an array of digits. I guess that's reasonable. Iterate the array of digits. And then the array would be used to convert to base 7 at some points to check if base 7 is the same. Okay. So I have digits is going to be an array for every, let's say, is odd is going to be true. I think digit starts with 1, to be honest. And see, while, or let's see, count is going to be 0, sum is going to be, answer is going to be 0, while the count is less than k. If maybe I should just skip over the trivial cases. Is it worth it? No, it's fine. Count is less than k. How would I do this? If I'm dealing with an odd number of digits, digits is 1. Digits is 1. How do I quickly deal with this? Count is k, it's odd. So I want to convert the 1 to base 7 and check. Maybe I should be starting with things that are bigger than this. 2 digits number. It's kind of confusing. Too many ways, or too much I want to do. not near enough ideas how to do it. So first things first. I have my array of digits, and my array of digits should be just like the front stuff. Maybe I'll call this the prefix digits. Prefix digits. So currently it's just 1. And if it's odd, then well, maybe I have my suffix digits as well. Currently my suffix digit is just nothing. Suffix digit being kind of what I would try to append. So the value of the thing, I don't want to create the value each time. I don't need to create the value each time. But I need the k value, or the k base value of the thing. K value. So if I convert 1 to base 7, it should still be 1, but how would I do that? Place value. So you iterate over each digit, multiply that. Iterate over all the digits. So if you have let's say you have 12 in base 10, or 12 in base 10, you want to convert that to be something in base 7. The way that you do that would be iterate over each digit starting with the 1st digit. You add that digit times the place value, and you increase the order of the place value by the base factor. So you do 2 times 0, and you do 1 times 7. Okay. Say k value in k, value base k. So, and then I have place value starts with 1, and then for each value in the suffix digits, actually for each digit in the suffix digits, then the value in base k is increased by the place value times the suffix by that digit. And then you increase the place value by k, by a factor of k. And then you iterate over your prefix digits in reverse order for each digit in the prefix digits. This is bad. This is creating the reverse array. I don't know if you want to do that. For each digit in prefix digit, for each index in the range of the length of prefix, whatever, length of prefix digits. -1 to -1, negative 1. Then the digit is that prefix digit at this index. So you go from the last prefix digit to the front prefix digit as the order, and then the value in base k is again added with the place value times the digit, and the place value times equals k. And then, oh geez. And now that you have your value in base k, you need to check this palindrome. Okay. How do you check this palindrome? Something in this is value, so you need to say what's the quickest way? Convert it to a string, convert that string into an array of digits. Fastest way to check if number is palindrome. Python. Convert a string, compare it to its reverse. Okay. So return if, okay, actually, so say string num is equal to string of the value. If string num is equal to string num reversed, actually just return true if this is, or false if not. If is palindrome of this value in base k, then let's go ahead and just print it. And I'll increment the count and return nothing. Yeah, this is just not going to work, is it? Actually, I'll just return immediately, because I never actually changed any of the digits, prefix digits. Line 19. You should just return, like, you should print 1, hopefully. Yeah. Okay, so I think I just need to also increase the place value, increase the prefix digits. Prefix digits of the last thing plus equals 1. And then if the prefix digits, actually, yeah, if the prefix digits, if the prefix digit is now equal to 0, then that triggers a spillover. Then it would change the next digit over. Okay, so it changes the next digit over. And then be the prefix digit -2 equals plus equals 1. No, it doesn't equal 0, it becomes equals 10. Then that thing should become 0. And the leftmost one, if it's odd, well, so prefix digits, how does this work? If it's odd, you're changing your ones digit. If it's even, if it's odd, you're changing your ones digit and not really changing anything else. Actually, so let's consider this prefix. When the prefix digit changes, the suffix digit changes if it's an even. Like 10 becomes 1000, 01. And when you change 10 to 11, it becomes 1001 or 11,000. Like here, right? You go from 10 to 11. So 10 is the prefix digits, 01 is the suffix digits. So when 10 goes to 11 by changing the last prefix digit, that changes the first suffix digit if it's an even number. But if it's like 10 to 11 on a 3-digit number, then the suffix digit still stays at 1. So if this is not odd, then the suffix digits increases by the first suffix digits increases by 1. If it's not odd. Okay. Yeah. And then that being the case though, if it is odd, okay, yeah, if it is not odd, then it does that. In case, then let's say you're dealing with 10. When you change this thing, it changes this suffix. And then when you go from 19 as an array to 110 as an array, then you want to change the next leftmost digit. You want to change the next leftmost digit. So let's say the leftmost digit is going to be at index, leftmost index is going to be index 0, while the leftmost index, or while the prefix digit of the leftmost index, how do I want to do this? Let's say the leftmost digit is 1. Prefix digit of the negative of the leftmost digit, leftmost index. Well, that thing is equal to 10, then change it. Prefix digits of negative leftmost digit, leftmost index becomes 0. Leftmost digit, leftmost index is increment by 1. So now we're dealing with second to last element in that array. And prefix, it's going to work if this might go out of bounds. Let's just not worry about the bounds case. The more general case, if it doesn't go out of bounds, is now incrementing that digit by 1, and then you do that a bunch of times. So that thing could be a 9, it changes to a 10. At that point, it does the while loop again, changes that back to a 0, goes to the next leftmost digit, changes that up by 1. Each time I do this, I need to change the suffix digit as well. So the suffix digit here, let's also worry about whether or not it's odd or even. Eeks. So I think here, if it's odd, I don't want to do this. So currently, let's say I'm dealing with the prefix of 19. So I'm dealing with a prefix of 19 and a suffix of 91. Is odd as false. So if I change this to become 110, then I should change this to become, I'm already doing that, I'm already changing this. So when it becomes 110 here, it becomes this 110 here. And that's this stuff right there. So now when I fix this, when I change that the prefix becomes 2, 0, hopefully I'm going to change this become 0, 2 here. So suffix digits, ignoring the is odd part, suffix digits of the leftmost minus 1. If it's 1, then the leftmost digit is 0. And then once I increment it, I now change the suffix digits of the leftmost digit, leftmost index is incremented by 1. And how does is odd or is not odd play into this? So if the prefix, so let's say the prefix is same deal, 1, 9. The suffix is just going to be 1 at that point. Is odd is going to be true. So the one number is 191. I change this to become a 110. Suffix is still 1. So this becomes 0, and this becomes 2. And I don't do this if it's odd. Don't do this if it's odd. Well, I don't do this part because there is no this part. But I do this part, right? I do change this to become a 2. So, but then the leftmost digit at this point is going to be, leftmost digit at this point is going to be 1, and I can't do suffix digit at index 1. Huh. Maybe I need to do suffix digit at Maybe I shouldn't keep track of a suffix digits array. That work? Maybe suffix digits is stupid. It's just a lot of work. For something that's like a copy and yeah. Okay. This is just stupid. Suffix digits is stupid. So if I just work with prefix digits, then what's going to happen? One less of it is going to be used as the suffix digits. And I want to work with it backwards. So if it's 10 comes 0, 1. So let's see. 1, 9. 1, 9, the suffix that is 9, 1. So I want to go from the prefix to the prefix minus 1 if it's odd. So if there's like 4 numbers in the prefix, then I go through the first 3 as the suffix in order. Okay, so for each digit in the range of the length prefix digits minus 1, I'm treating this as the suffix. Go through first n minus 1 digits of prefix, which is as suffix. So for example, if the prefix is like 1, 2, 3, go through 1, 2 as suffix to the palindrome that is, or palindrome 1, 2, 3, 2, 1. So the first n minus 1 digits of that, I get the digit as the place value. No, this is the wrong range. This is for each index. I guess I can go through now, index. And then the value is going to be the prefix digits at this index. Actually, not the value, the digit. And then same thing there. And then I think that's fine. Actually, is it supposed to be minus 1 only because it's odd? That's right. Yeah, this is only if it's odd. So maybe I use is odd is 1, 0 if let's say odd offset. So this thing odd offset is just going to use here. So the suffix digits can be 3 or no. I use 1 less prefix digit as suffix if it's an odd offset. Okay, that's fine. And then I still do the same thing in reverse to get the higher order value digits. I still do that. and then changing the prefix digit by increment. And then I change the suffix digit. No, I don't have suffix digit anymore. Then I increment. I say my leftmost digit is 1 index, which is kind of -1. But, so while the prefix digit is negative, the leftmost digit, leftmost index. Well, that's a 10. Increment, change it to 0. I don't have a boolean for this odd anymore. I don't have suffixes anymore. Leftmost index goes increased by 1. And then prefix digit increments that value by 1. Okay, so I think this is fine, except for the fact that I wonder, except for the fact that I want to actually add new prefix digits to the front of the prefix array rather than the back. So do I want this to be a deck? Double-ended queue. If I wanted this to be a double-ended queue, then that would probably make this, and I never really append to the back end of the queue, then I really should probably be working with the prefix digits backwards, to be honest. Because it goes through 1 through 9, the 9 becomes 0, and then I append a 1. And then, yeah, this should be, prefix digits should be backwards. Yeah, fuck. So then the prefix digit is a suffix. Oh shit. Oh my god. So I'm working through my suffix digits, where the suffix digits are going to go through 1 through 9, and then the next thing is 10, but the 10 is going to be 0, 1, and then if I go through the suffix digits, then when I increment the suffix digit, then I'm incrementing the wrong spot in that case. Huh. Right, just changing it to deck. An array versus deck where these are all the things that is probably still pretty small. Okay. Prefix digits incremented by 1. Okay, so this is, so if I take the last thing in the deck, last thing in the deck, so if it's 10, while prefix digits, so this probably should be 0 actually. So this is like negative of 1 minus 1 plus 1 plus the leftmost index, or negative 1 minus the leftmost index. This probably looks a little better. And then again, this is negative 1 minus it. This looks horrible. Or maybe should be negative the leftmost digit minus 1. Okay, so I have that. Leftmost index increments by 1. Prefix digits is now this. This is not going to be correct. I guess leftmost digit could be there might be only one. So I think maybe I should be starting with this inside the while loop. While prefix. No, this is no, I need a block here. While leftmost index plus 1 not equal to the length of prefix digits. Yeah. Actually, it should probably be reverse. Well, this is true, and that is true. So I just want to block it from spilling over incorrectly. So if you increment the prefix digit by 1, the last prefix digit by 1, and so it becomes a 10, and let's say it's a 1-digit number. So that last digit is 10, so it should eventually become 0, but it doesn't become 0 using this because it needs to spill over and create another digit rather than spill over and to change the next digit because there is no next digit. So while this is true and also 0 plus 1 is not equal to like a 1-digit number, then change it to 0, go to the next digit. Yeah. And then if it's still the case that the prefix digits at the leftmost index, which is currently which would be 0. So I guess if the case of prefix digit of 0 is equal to 10, then prefix digits of 0 is equal to 0, and then you would change well, how does it roll over? So if it's a 2-digit number, so 10, so 9 spills over to 1 if it's currently is odd. Because it's a 3-digit number, it goes to 4-digit number and it changes, it's no longer odd. So actually, if is odd offset equals 1, so it's odd, then odd offset equals 0. And then prefix digits of the front is now, oh, I'm in the wrong spot, if odd offset is equal to 1 equals 0, prefix digits of 0 becomes 1. So 99 becomes just 10 again. Else odd offset is now equal to 0. Prefix digits of 0 is equal to, now I need to append prefix digits of 0 is equal to 0, and then the prefix digits dot append left. I think it's actually append capital left. Append lowercase left. Maybe I'm confusing with Java or something. Append left a 1. Actually, I think append left 1 is fine. Error chain is odd. Odd offset. No. So odd offset should now be some 1 because now it is odd. Okay. Okay, so let's say count. Say that actually. See if this crashes or not, if where it crashes. Interesting. Not crashing yet. Not working yet either. Eeks. N is K is 3, it shouldn't have 3. Well, yeah, K is 3. Shouldn't be printing 3, I don't think. Because 3 converted to base 3 is going to be 10. Value base K. Okay, let me think here. What's going on? N is 7. So it's going through here. Okay, let me go ahead and print the prefix digits. So 1, 2, buckle my shoe. Okay, so it goes through some number of them. And then it stops. Okay. Prefix digit. So 1 is here. One is a palindrome, 2 is a palindrome. 3 shouldn't even be possible in base 3. So 1, 2, 3. If I convert 3 into base 3, oh, I'm doing it in reverse, am I? I'm stupid. I'm considering this number that I'm creating is base k rather than base 10. And then I'm converting that number base k to be base 10 rather than the other way. Okay, so I have the I have value in base 10 actually. Yeah, this is all base 10. Oh, this is so stupid. So, and this is going to be slower than if I did the other way around. So, I have to change this. Say the value is 0. So for each index in the prefix digits, so like 199, it's 19, first with 1, here, place value times, so it'd be, yeah, the place value times the digit still, and the place value times this factor of 10. Okay. And now I need to actually convert this value that's in Orion base 10, actually value b10 to be extra precise. Value base 10 and okay, so I have some value in base 10. I need to convert to base k. Oof. Convert base k value b10. And what I would do here is I need the biggest place value that is smaller than biggest power of the base that's smaller than. Actually, does Python have a conversion? Probably not. Yeah, probably not. Convert to base k. Largest pow is going to be math dot log Python log base. What is pow? Or what log are you using? Calculates log base 2. So argument and then base. So math value base k. And then for each, let's say, place value starts with place value starts with k to the power of the largest power. Does math.log return an integer? I think this should be int. It might need to be rounded up. We'll see. Yeah, so pow. I guess you probably don't need round up. No. while value is greater than 0. Value is 0. While value is greater than 0, value minus. Oh my god. The digit is going to be the value divided by however many times the current place value fits into it. Convert value is going to be equal to convert value times 10 plus the digit, and then return the convert value. Okay, so let's go ahead and just test this out. Print convert base k of, let's say, 13. This is not going to work for. Yeah, that should be fine. This is 10 timeout. Need to actually have changed the place value. Place value. Value minus equals digit times place value. The place value divided by the base. Okay. Okay, let's see if this is right. 13 and base 2 is 8 plus 4 plus 1. 13 base 3 is going to be 9 plus 2, 9 plus 3 plus 1. And 13 base 7 is going to be 7 plus 6. Okay, that seems fine. Okay. So I have my value in base 10, and then my value be k, value menu, is going to be convert to base k of this value in base 10. And if that's a palindrome, then count it. Oh, value in base k. Well, that's not good. 1, 2, 1. 1, 2, 3, 4, 5, 6, 1. Interesting. One. So it doesn't seem to actually increase the number of elements in prefix. Okay, so prefix digits. Let's go ahead and just print out here. Oops, prefix digits. So how many is it going through? It's just going through like 1, 2, just ending here. Okay, so 1, 2. So the prefix digit is 2. So Leftmost prefix digit is 2. Attack is 2. Okay, let's go ahead and just print anything value B10. So the value in base 10 is 2. The value in base 2 is 1. That's incorrect. I thought I just got it correct. What's going on here? Convert value. Oh, fuck me. I'm so stupid. If it's a palindrome in value in base 10, no, that's right. Value in base K. 10 converts to 1. What the heck? What the heck? Or 2 converts to 1. 3 converts to 1. 2 math.log value 2 is 1. Yeah. So 1 should be 10. So when I subtract it, it becomes 0. When I subtract it, becomes 0. So while the value is greater than 0, and then the value becomes 0. Then if it's a whole thing before it becomes 0, then it needs to, oh, okay, yeah, that makes sense. Yeah, this is incorrect. Because it could subtract the whole thing and makes it a 0. Then you still need to have more zeros when you convert it. So I think this should be when the place value is so the place value is 2, then the place value becomes 1. While the place value is greater than 1. So when place value is 1, then you need to multiply the convert value times 10 plus the final digit. Plus this final digit, which is the final value. Alright. So that looks correct. 1 converts to 1, 2 converts to 1, 0, 3 converts to 1, 1. All these things are correct. 7 becomes 1, 0, 8 becomes 1, 1. Okay, so that's fine. So why did this thing stop? The count is incremented if it's a palindrome. Oh, I'm doing stop when the palindrome is the number k, rather when the palindrome is the number n. And this palindrome count plus equals 1, answer plus equals this value. Value B10. Alright, stop printing out stuff. Just try to make it. See if that works. And I probably want to return the answer instead of 0. Ah, shucks. Okay. Let's go ahead and print out the palindrome set it's found. Print out the value in base 10. Right, so this first one is 1379, that's fine. One, 2, 4, 8, 121, 151. Oh boy. Oh noes. Okay, so this is iterating from 3 digits to 4 digits. This should not be 121 again. Yeah, that's an issue. It's not iterating correctly from 2 digits, from 3 digits to 4 digits. So leftmost index is 0. So then the leftmost index that seems so correct to me. Two one two 199. So it should be 19. It should be 15 16 17 18 19, and then 19 becomes 21. Okay, so that means that the prefix, the leftmost digit is 0, index is initially 0, then it becomes increments to 10, leftmost digit is now 1. Wait. Hold up. Let's see. It's 19. So the length of the prefix should be 2. If it's 0 as if the it appended correctly once. Otherwise it wouldn't do this to this. No. It's already odd in that case. If the front thing is 10 and it's odd, then it resets to be 0. If the front thing is odd offset becomes even, and the prefix digit becomes if it's odd, then 1 through 9. I think this is backwards. Yeah, I think this is backwards. Odd 1 through 9, and then odd becomes even, and it's the pen when it's odd becoming even. Yeah, this logic is just backwards. No, no. Odd offset becomes even. And then this thing is there. Odd offset becomes even. The prefix becomes 0. So 1 through 9 then becomes 10. And then it's only when you have evens that you don't reset. Yeah. Goes infinite instead. Okay, excellent. Timing out. Huh. Is it timing out here? Is it timing out? If the odd offset, that odd offset becomes even. 9 becomes 0. You add a 1, and that becomes 10. Otherwise, if it's not odd offset, then it's an even offset. And now the odd offset becomes 1. And your starting digit is now 1. I mean, this is the only, unless it doesn't find it here. Let me do a very small test case. Does that still work? Okay, that still works. Three, 7, 7, 17. Does that work? No, that doesn't work. Alright. Let's say loop is 0, loop is incremented, if loop is equal to 1000, break. And it could be here that it's going infinite, or here. So I'm just going to hope that it's the outermost loop that's going infinite. Although I suspect it's not. Okay, it is the outermost loop that's going infinite. Print the prefix. Oh, there's no prefix. Print the prefix digits. Oh boy, prefix digits 1, 9. Ah, so it's going infinite in this by not actually going through all the digits. If the frontmost prefix digit is 10, and it's an odd, like it's 1 digit number, then the odd offset becomes 0 and it's even. Prefix digits of 0 becomes 0, and then you add a 1 to the left side. Mm-hmm. 1019. Those are the only two that prints out. 1019. 19? How do I get 19? After you change it, it should be like 10, and there should be zeros in the other spots. Prefix digits. So leftmost digit is 0. Increment it. Prefix. Whew. Let's just fix this. Pretty sure it's pretty close to the last error. So what's going on here? 1, 1, 9, 1, 9. Alright, maybe I should just print out each time it does the loop, what it converts it to. Okay. This is going to be a lot of printouts. I think I just need 100. Alright. 1, 9 becomes 1, 1. Interesting. 1, 9 becomes 1, 1. 1, 0, and then becomes another 1, 0. Ooh, boy. Oh boy. That is not good. So I increment the last digit. So 1, 0 becomes 1, 1. The leftmost index is 0. At the prefix digits, let's go ahead and just print right here. Changing leftmost. Okay, changing leftmost here. Oh, that should be a 2, 0. Why isn't it this one changing leftmost? I guess this is not because it's not because it's actually hitting the if statement. This condition is false. So seeing this thing, it makes it into a 1, 0. Okay, and that's why it's printing it twice. Okay. Yeah. Okay. So it is iterating through from 9 to 1, 1. That's not great. Changing 9 to 1, 1. Changing 9 to 10. Changing 9 to 10. Prefix digit at Oh, fuck me. I'm so stupid. No, is that right? Yeah. Okay, 2, 0, 3, 0, 4, 5, 6, 7, 8, 9. No, this is not right. Changing leftmost. No, actually that is right, because it needs to repeat the 2-digit numbers again. Let's go bigger loop count. Let's go 200. 9, 9, 9, 10, 20, 9, 9, back to 1, 0. Okay, this doesn't really print out the ones that I really want to see. Um, oh, I missed someone said hi. Alright, so I think this is probably fine. Okay, is Pally. Change the leftmost a bunch of times. I think maybe. Oh my gosh. 717. Okay. Okay, so what is it considering as palindromes, and why isn't it getting it the correct number of times? Huh. And a 17. 1, 2, 3, 4, 5. So it's getting the first 7. No, it's getting the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's getting the first 11, but then it stops. Why would it stop? Oh, because I said I'm so stupid. I had a loop that stops, and so I was questioning why it stopped the loop. Okay, that's better. So 1, 6, 5, 6, 2. Oh boy, that's not good. So it skipped out. It didn't skip out actually. What is this huge number that's in there? And why is it getting here before here? So it's like 6, 1. This is not even a palindrome. Oh boy, oh boy. 6, 1, 2, 5, 5, 2. So what is going on? What is going on? 6, 1, 2, 5. 6, 1, 2, 5. Huh. So it's doing 3-digit numbers, and somehow it's doing a 4-digit number in there. 4-digit number. So the length of the prefix is probably 4 digits at that point, or is the length of the 3 digits? Let's go ahead and find out. What is my prefix that I'm dealing with here? Prefix digits is a 4-digit number at that point. Okay, okay. But why? Why is it 4 digits? And then those 4 digits is actually before these 4 digits in the order that I'm processing it. Okay, I think what I need to do is I need to actually do this thing. Print prefix digits when I'm doing this exchange. Okay, so overflow. This is before. And then print overflow after. Okay, so 10 becomes is a 1 digit, and then the 1 digit becomes the 1 digit becomes a 2-digit number. Yeah, 10 becomes 0, and it's a 2-digit number 10. And then the second time it does it, this is the same thing. It's a 2-digit number. 10 becomes 0. And the next time it does it, it's going to overflow to become a 3-digit. Next time it does that, it overflows and still becomes 3-digit. And the next time it does that, overflows and becomes 4-digit. 4-digit, 4-digit. 4-digit to 4-digit. Wait. 3 digits, 3 digits. What am I doing wrong here? 1 digit becomes 2-digit. Not 1 digit becomes 2-digit. 2 digits becomes 2 digits. And then 2-digit becomes 3-digit. 3-digit becomes 3 digits. 3 digits become 4 digits. 3 digits becomes 4 digits. This should not be done. That's too big. 6125, it's too big. Why is it? That should be treating it as a is odd. So it should only be doing 612. Odd offset doesn't seem to be correct in that spot. Okay, so let's go. Odd to even, even to odd. Alright, first one's odd to even. So even, so these are treated as the even prefix, so it'd be like 1001. Even to odd. So No, odd to even. Boy, wait. Odd to even. It should be treated as one. Fuck me. If it's an odd offset, it's an even offset. If it's odd, then how does that work? 1, 0. When you have odd numbers, you want to go through every number. No, if it's odd, then you want to treat one less than the number, the prefix digits, to make your palindrome. If it's an even, so like odd number, so odd digits would be like 10. 10, you want to treat it as 101. Or you want to create the 101, so you want to have one less digit that you're looking through in your prefix digits. One less digit. Otherwise, you want to go through all your digits. So if it's an odd offset to an even offset, you're actually going from an odd count. Say odd offset. You start with a one-digit number. One-digit number 1 through 9. And then where a one-digit number 1 through 9 has an odd offset of 1. And then you have even numbers. 10, 10 through 99. I think I screwed this up. You have 10 through 99, you're still using one prefix, so the odd offset is still 1. So when do you change it to using all the digits? So what's going on here? One digit becomes 1 to 9. Two digits becomes 1, 1 to 99. Three digits. 10. This becomes 101 to 999. 4 digits is 1001 to 9099. So you're looking here, one less, one less, one less. Huh. No, this is one less. You're looking through all of it. One less, all. One less, all. So your prefix is one less on the odd and all on the even in order to create your suffix. One less on the odd, all on the evens. So That should be right. 7-bit odd to even. Then odd offset should be 0. Odd to even, odd offset should be 0, but then you don't necessarily change the prefix amount. I think the prefix amount stays the same here. So it should be resetting back to 1 here. Didn't I already do this? Prefix digits at 0 becomes 1. Prefix digit append left 1. Doesn't seem right. Oh my gosh. Oh. Oh, oops, I forgot to remove this print. Still timed out. Oh boy. Okay. I don't think this print is going to be the thing that makes this faster. Yeah, this is so slow. But it's a solution. I mean, 31 milliseconds. That's pretty darn quick. Versus 6,000. Well, that's kind of slow. I wonder. So one thing I can do is I can change it from using prefix digits to an array, because appending is a lot faster than append left on a double-ended queue, appending to an array. But trying to think if there's any logic here that is extremely bad. I guess. I think maybe if I had a fixed array of powers of the base that I can just refer to, rather than having to calculate the convert value each time. Yeah, maybe that was something. Powers of k. Let's say it's I think it could just be how big should it be? Let's say it's an empty array. for k for index for PAL in range of do 10 powers. 10 powers might not be enough though. This 2 to the 10th is just 1,000. Let's say the power is currently 1, while power is less than 10 to the 9th, which is the size of like roughly the size of an integer. Powers of k dot append is power, and then power times equals k, and then I'll just reverse it. Okay. Is that correct? So let's see the powers of k. And then I want to use that when I'm converting. So how to use that when I'm converting, rather than having these value times value, the digit is equals to value divided by place value. So the place value is already calculated. So I think so if it's something like 121 in base 10 and convert to base 7, and then the number of times. So I still need to know the biggest power, which represents the highest index, represents the highest index. Convert values to 0. So if I have an array that is like 4971, I have 121 as the value, then I do maybe powers of k should actually be in this order. So it should be in increasing order from 1 on 1739. Because then if I do 49, log of 49 base 7, that's 2, which is index 2. Index 2 would actually give me 49 to the third. 0, 1, 2. So convert value is going to be you need to take the biggest one. Why am I converting this to an integer? Why not convert it to an array? That'd be much better. Because then the array can be compared to the reverse of itself rather than comparing to a string addition. So the place value, while this place value, actually I think maybe this should be -1. Largest power -1, and then while large PAL is greater than 0. Wow, let's type that pretty bad. While large POW is greater than 0. Convert value dot append the value divided by powers of k at this large POW index, and then large POW minus equals 1. And then I need to do value minus equals, or value just mod. Yeah, this is the same thing as mod. Mod equals the powers of k at this large power. Like, let's say we're dealing with the base 10, right? So if you have an array that is 1, 10, 100, 1000, and you're converting it into its kind of array of digits there, like a number like 314, you do 314 divided by 100 gets 3, that's added to the array. Change the index, so you're now dealing with index 1, and that's going to give you like tens place. Actually, this thing is for that thing. And then 314 mod 100 is 14. Now your index is 10 in the powers of 10 array. Okay, I think maybe that might be substitutable. And I guess here you're going to return you're still going through it the correct number of times. Large power, I think this might just be return this array. And then this is now an array. Value in base k, and this, if is a palindrome, is just the same as if it's the same thing as itself in reverse. This is obviously a little extra right now because it's all kind of based on strings. Excellent, so it does it wrong. Okay, let's go ahead and just verify that this is actually doing stuff. Print convert base k of, let's say, 15. Okay, so it's printing out 5. Oh, what? So 15 in base 2. Ooh, that's not good. Okay, so I'm going to go ahead and print out the powers of k array. Alright, so that looks fine. So if you have 15, it should be 8 goes into it once. 8 goes into 15 once. I think, okay, this is just off by 1, I think. Should be not -1. 15 is 8 plus 4 plus 2. Okay, it's still off by 1. It's not doing the last digit correctly. Okay, I think this thing probably needs to just append the last thing. All large powers greater than 0. Maybe? 3, 15 into base 7 is 1, 2. It's 2, 1. Yeah, it's just in reverse fashion. I'm appending. I am appending in reverse fashion. I guess it doesn't matter because if you check, if it's a palindrome, it's a palindrome in reverse as well. But technically, this is converting 15 to 21 in base 7, which is correct. Which is correct. But then it's converting 15 into 111, which is incorrect. It's missing another 1. 8 plus 4 plus 2 plus 1. So why? Did it for the other one correctly? Well, actually, it's converting 15 base 3. Base 3 is going to be 1, 9, 2 6s. Yeah, it's missing a 0 here, actually. Wow, what coincidence. 15 base 3 is 1, 2, 1. And then 15 base 7 is 21, so I got confused. Okay. And here it's 2, 15 base, it's base 7. Yeah. So it's missing the 1, so it's actually just needs to append the last value. Convert value, dot append value. Okay. Alright, so this thing hopefully can be removed. See if that works-ish. Alright, let's see if it works better on all the cases out of range. This index out of range. Okay, so 10 to the 9th isn't big enough. I mean, how much bigger is it? 10 to the 10th? Okay, well 10 to the 10th did fit it. Okay. 10 to the 10th did not fit it. 10 to the 11th? It's a really big guy. I generally thought it was like, integers don't go that big. Okay, even slower than before. Excellent. Well now. I guess it's still the same. No, I think it's slower than before. 5. Oh no, actually I improved it by a factor of 20%. Not bad. Or by 20%, not a factor of 20%. Go through all your counts. Do your various things. Convert. I guess maybe creating these subarrays is pretty bad. So if as a palindrome is for index and range of length of value, divide by 2 if the digit at this index does not equal the digit at the negative of the index 0, -1 minus this index, then return false. Otherwise return true. Okay, so at least this one gets rid of creating a bunch of arrays. Alright, well, it changed the memory. No, it didn't. It's the exact same. Interesting. Interesting. So I guess I'm creating a bunch of arrays each time. I mean, I could use a singleton array and change the values at those indices within it. I don't think would that really affect things? I mean, the memory's still fine. But, yeah. So I guess I could also interesting. For every index prefix. Like I'm using an array for this, but I could just be using, because I'm using an array for this, and then I'm converting the array into I'm converting the array into a palindrome. But the issue with this is it's actually quite tedious to iterate over the things. Whereas I could have just incremented by 1. And it's still the same process of iterating over all the values of your array. For every index, blah, 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 blah. So if I didn't iterate over this right like this, then what would I do? I would iterate over. So if I have a prefix that's literally a number, like 1 through 9, 1 through 9, 10 through 99, 10 through 99. And if I wanted to convert that thing to the palindrome number, then I would do the prefix number the prefix number times some power of 10 to move it over the correct number of spaces, plus a while loop to iterate over a while loop to iterate over the other stuff. So the prefix I guess if I have prefix that is 1 through 10, 1 through 10, or 1 through 9, 10 through 99, then the suffix when it's 10, it's 10 is 1. What am I thinking of here? So the suffix is incrementing here from 1 through 9. And the suffix here is going from, is it going from 0, 1, 10, 11, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1. So it's iterating over the tens. And then when it's done with 9, 1 comes 2, 0, 0, 2, 9, 9, 1, 0, 2, 19 to 20. 9, 1 to 0, 2. Like I'm trying to figure out whether or not I can just use a for loop that iterates over some prefix number that's incrementing an integer, but then the suffix number is harder to do. I guess the suffix number still I need to iterate over the prefix number. Eeks. So if the prefix is just an integer itself, and I calculate the suffix on the fly using a for loop. Yeah. Ugh. Is this actually going to be faster? Rather than using a deck for it. Okay. I'm gonna spend 10 minutes on trying to do this. Prefix digits is gonna be 1. Place value. Okay, let's do the easy part first. Prefix digit just increases by 1. If and then I can just say if this is now a power of 10, if how do I tell that this is the power of 10? The remainder, if the log base 10, how do I tell this is power 10? increment by 1, and then kind of like 100 or 1,000. Oof. If prefix digits, if math, okay, Python, to tell if number is a power of 10. What is going on? N is 0 log value. If the log value of it is equal to integer of the log value. So you take the log of it. Okay, sure. Math.log base 10. Math of log 10. If math of log 10 of this prefix digits. I guess it's no longer prefix digit, it's just prefix. The prefix is starting with 1. And then prefix is incremented, and then if the prefix log 10 is equal to integer of the log value. The log value is equal to the integer of that log value. Okay. The log value is equal to the integer of the log value. Then depending on whether or not this is an odd or even, I change the amount. So if odd offset, I don't have odd offset anymore. Let's say is odd is true here. If this is an odd number of digits, then is odd is now false. And I want to go back to the same number of digits, but with 1 leading. So same number of digits, but with 1 leading. So I think it's just divide by 10. So prefix divide equals 10. So 1 goes through 9, 9 goes to 10. And then 10 goes back to 1. That doesn't seem right. No, odd offset is... Yeah, actually that's right, because then the next line goes 1, 1, 1, 2, 2, so it's an odd, so it's the same number of digits. Yeah. Else is odd is now true, and I want to keep it, so it goes 9 and 10. Okay. Okay, I think that's correct. So all this jazz can go away. So the prefix is now non-array, but just an integer. And now I need to find the way to create the actual value. So maybe I should be tracking the number of digits this thing is. number of digits it is. Because then I can use that number of digits to help me figure out which digits are suffixes. So I'm going to say num digits is going to be initially 1. And here, num digits, when it's odd, the num digits here is still the same. Num digits here is going to be incremented. Yeah. And then here, when I create my value in base 10, I want to go something like a prefix plus 10 times 10 to the power of, I think I should have a powers of 10 array as well, so that has to be calculated as powers of 10 power is power 10 is 1, powers of 10 dot append this power 10 and power 10 times equals 10. I think that's fine. Okay, so value times prefix plus 10 times the, or the powers of 10 powers of 10 times the number of digits. Okay, is this right? Is this right? It's probably not right now. No. So if it's a 1-digit number, then you want to do the prefix, which is 1 or 2 or 3 or 4 or 5 times 10 to the first 10 to the 0 power. So 0 index. So num digits minus 1. But then if it's num digits and it's so the next iteration, it's also 1 through 9, and it's 1 digit. But this is an even number. Even number would want those values to be multiplied by 10 to the first. So is odd. If it's even, then okay, I'll just break it down. If it's odd, then do this. And otherwise, the initial value is prefix times powers of 10 to the num digits. And then if I have a 2-digit number, let's say it's 11, then I want it to multiply by 10, which is index 1 in the powers of 10 array. And if it's 2-digit, but it's even, then I want to multiply by 1,000 by 100, 10 times 100 to make it in the thousands. Okay. So place value is 1. I don't think I need place value now. And now I need to add the suffix part of it. So I need to go through for every index in the range of num digits minus 1. No, num digits if it's odd versus even again. Okay, I think maybe I should just have two separate things here. If it's odd, it starts with that, and then for every index in range of num digits minus 1, then I want to add, I want to go through so if I have an odd number of digits. So, or let's say my digits are, say my digits are, what is going on? So my digits is 1, 2, 3. That's odd. So I want to convert it to 1, 2, 3, 2, 1. So I want to go through the first two digits of 1, 2, 3 out of the three digits that are there. So if it's 3, then it's going to go through 1, 2, 3. If it's 2, then it goes to 1, 2. So num digits minus 1 is fine. And for each digit here, I want to find the digit and then multiply that digit with the appropriate place value in powers of 10. Okay, so I think digit would be how to do this. I guess I can say current is equal to my prefix, and then while, well, I need to drop the last one, so prefix divided by 10, while current is greater than 0. Then I can say the last digit is current mod 10, so this is like 2 out of 123. So divide by 10 is going to be 12. Mod 10 is going to give 2. And 2 is going to be 2 needs to be multiplied by 10 to the first. So I'll say power index is initially num digits minus 1. Num digits is 3. Num digits minus 1 is 2. Num digits minus 2? That seems a little excessive. Yeah, I guess that's right. Power index is num digits minus 2. So 2 needs to be 10 to the first. So value base 10 plus equals that last digit times powers of 10 at this power index. Power index is going to be decremented, and then current is going to be removing the last digit. So then current becomes 1. 1 is greater than 0. Oof. I don't even care that 1 is greater than 0, right? Because even if it's 0, I need to actually still... No, that's fine. 0, that means that... That means I'm not changing the order of magnitude of the value base 10 based on it, so I think this is fine. Yeah, while current's greater than 0. So then current becomes 1. 1 is greater than 0, the last digit 1 is 1. And then 1 times power 10, that index 0 is 1. Power index becomes 0. Yeah. Okay, I think this is correct for the is odd case. And then for the even case, so I want to do something where 1, 2, 3 becomes 1, 2, 3, 2, 1. No, 1, 2, 3, 3, 2, 1. So value value v10 is already set up. Current equals prefix. Power index is equal to num digits minus 1, I think. And then while current is greater than 0, last is equal to current mod 10. Value b10 is plus equals last times powers of 10 at this index. Power index minus equals 1. Current divided equals 10. Okay, so power indexes can be 3 minus 1 is 2. And then current's going to be 1, 2, 3. And then last is going to be 3. It'll be 3 times power 10 to the second power, which is 100. So it adds 300. Then it goes to the second index. And then current becomes equals to 12. Okay, I think I finally got there. And then I do the conversion. Okay, let's see how much this crashes. List on line 28. Powers of 10, append power 10. That's one too many P's. Power of 10 versus powers of 10. Probably consistent, I think. 53. Oh, shucks. Went infinite. Oh, didn't want to go infinite. Oh my god. Oh my god. Well, it's decreasing by 1 second each time. Mamma mia. Oh. Well, sometimes you gotta say enough is enough. I think I spent more than 10 minutes trying to do that conversion. I mean, it definitely was a significant, or at least statistically significant improvement, even if it wasn't actually whatever. Okay, anyways, I'm done. I think I expended enough effort on this problem to say that I gave it a good old try. All right, summary. So what I did, which is again not necessarily the most optimal solution, but it is a solution. So no, so basically, I said consider constructing palindromes in sequence in base 10. For each, find the base k equivalent, probably best in array form, of digits, and check if also a palindrome in base k, increment count, add base 10 value to answer summation, answer total, and increment counter, return once n values have been found. Okay, so those are the key steps. So one is this, constructing the palindromes in sequence. 2 is this, finding the base k version of it in array form. 3 this. 4 is this, or like this is the ending 3. And then so for part 1, note that if you just note that the prefix of palindromes, basically the starting digits in base 10, have a particular pattern, in particular like this pattern, right? Submissions. Where would I put the pattern? This pattern right here, you can do a prefix array, or you can prefix array of digits, or you can do a single integer that has prefix. Can either use a prefix array of digits or a single integer for the prefix, which will increment with some logic to the next prefix in the loop. Have code to convert prefix to a full palindrome, and yeah. For part 2, this is kind of number theory. Use base number theory logic to convert a base 10 number to base k, where again you have basically maybe use an array of powers to cut down on some repeated calculations. So in general, for something like, let's say 1, 2, 3 and base 10, in order to convert this to base 7, you want to find the number of times the biggest powers of 7 goes into it. And so it's like 123 mod or divide by 49 is equal to 2. So that means there's a 2 in front, and then 123 minus 49 times 2 is 25, and then 25 mod 7 is 3, and 23 minus, or 25 minus 7 times 3 is, that's not 25, is 4, and then 4 divided by 1 is 4. So the conversion of 123 in base 10 is 2, 3, 4 in base 7. Two, 3, 6. Why am I so bad at math? 123, 25, 25. What? Oh, I said 120, 123. 2, 3, 4, yeah. Okay. Alright, and then the last little bit was, and yeah, so this was the conversion in here. Finding the largest power, and then while the largest power is greater than 0, I'm going to iterate through the powers that can still fit into the number, kind of figure out how much the largest power can fit into that number, remove that largest power, that multiple of the largest power from that number, and then decrement the power, make this into an array of digits. And then if the palindrome best, if also palindrome base k, and so if to check for palindrome, just compare starting and ending digits in array for each possible indice. Short circuit if short circuit to false, if not equal, and then otherwise return true otherwise. And then the rest is pretty straightforward compared to other logic. So palindrome index, you can check half the indices because the other half should be the same if it is palindrome. Compare it to the ending index. Alright, anyways, I am done. Time complexity, this is too long. This is going to be O of... So, by the logic of how many palindromes there are within the space of the numbered digits, I think it's on the order of the numbered digits that you're dealing with. So it's on the order of 10 to the number of digits that you're dealing with. Yeah. you're dealing with one digit, but then the number that you're dealing with, the number of digits is going to be log of the n, right? So is it just O of n? My thing was not O of n speed, it's O of super slow speed. O of 10 to the power n. Now 10 to the power 30 is just too slow, I didn't do that slow. 10, actually, not sure. I do know that palindrome counts increase by a factor of 10 for every 2 factors of 10 in this, well, basically 2 extra digits in the number. So I guess it's like, so maybe O of, I don't know. Really hard to say. This doesn't have a norm while loop. Like this is a construction loop. Like you're constructing things until you've constructed enough common things between the palindrome sets. So it's not like it would be harder than, I think this problem was intended to figure out how big the sets have to be in order to have k things or n things be in common. Yeah, kind of a number theory. Number theory problem to determine when the sets would have n common palindromes, and the sets being the base 10 sets. I don't know. It's above my level of knowledge or current ability. It's basically lets me O of. Do I actually store anything? I guess I store. No, I actually don't store anything. O of 1. O of n log base 10. O of log of n, since this deals, this might have an array of digits where the array would use, where the number of digits is on the order of log of n. Okay.